Okay, this is 3.3a, Isosceles Triangles. Okay, so here's some important vocabulary to start us off. So we have two different triangles that we're going to talk about this morning. So we have the isosceles triangles and the equilateral triangles. So if we first start with the isosceles triangles, we have a couple important pieces of information. So when we have an isosceles triangle, okay, we have this as our leg, this as our leg, saying that those are both congruent. This here is our base, okay? These here are called our base angles because they're on the base, okay? And then at the very, very top where the two legs come together, this is called our vertex. Okay, and that's going to be our vertex angle. So the vertex is where the two legs come together, and then the angle that the two legs form is called our vertex angle. So our legs are two equal sides. So remember, an isosceles triangle will always have two congruent sides. We have the base, which is our third side. Okay. So if I have a little triangle like this, even if it's sideways, this guy here is the base. The vertex is the point where the legs meet. Vertex angle is the angle formed by the legs. It's always opposite from the base. Okay, so if I look here, this is my vertex angle and it's all the way across from the base. So it is the included angle of the legs. Then we have our base angles, which are two angles on the bottom. So the two angles remaining. And then they are always congruent. So in an isosceles triangle, draw it again up here. In an isosceles triangle, if these two legs are congruent, then the base angles are also congruent. Okay, that's important for you to remember. If you look in your Nifty 50, there is the isosceles triangle theorem and the converse of the isosceles triangle theorem. Now, if we look over here at equilateral triangles, we know what the word equilateral means. Equilateral means that we have three congruent sides. So all three sides are congruent. Okay? If all three sides are congruent, the triangle is equiangular. And what does that word mean? All right, we know what that word means. We remember that from polygons. So equiangular, remember, is all angles are congruent. So if we have an equilateral triangle where all the sides are congruent, that also tells me that all three of my angles are also congruent. So an equilateral triangle is equiangular and vice versa. So that means an equiangular triangle is also equilateral. So those are our two important triangles. Now let's dive in a little bit deeper about more things about triangles. Okay, so here's some more vocabulary for us to talk about. The first thing is an angle bisector. Okay, so if I label my triangle here, A, B, C, okay? An angle bisector, let's say it comes down from here, it does exactly what we think it does. It's going to make these two here congruent. So angle 1 is congruent to angle 2. That tells me that AD, ray AD, is the angle bisector. Okay, so the angle bisector is going to come from the vertex of one of the angles, and it's going to cut that angle exactly in half. Okay, we know what that word means. Let's talk about median. So, median, if I label my triangle again, the median is going to come from one of my vertices, and it's going to go straight down. Now, what this does is it actually, let's say this is point M, this is actually going to cut this bottom side into two congruent pieces. So M is the midpoint of segment BC. That tells me that ray AM is the median from angle A to segment BC. It's generally not going to be the same as the angle bisector. Okay, and this is because we know that BM and MC are congruent, whereas over here we knew that angle 1 and angle 2 were congruent. We don't know anything about these segments here in the angle bisector one, and we don't know anything about the angles up here in the median. Okay, so here's some more vocabulary. We have the altitude and the perpendicular bisector. So when we talk about the altitude tells me that we can draw a line straight down from the vertex, and that's going to make a right angle. Okay, so if I label my triangle, we can say that this is A, B, C, and D. Okay, so I know that segment AD is perpendicular to segment BC because segment, let's try that again. Because segment AE is the altitude from angle A to segment BC. Okay, if we look at the perpendicular bisector, this is also a perpendicular line, but it doesn't always go through the vertex. Okay, so if I label my triangle, I have vertex A, B, C. This point here is F, and this point here is M. So I know a couple things here. I know that these are congruent. So I know that M is the midpoint of segment BC. Okay. I also know that line FM is perpendicular to segment BC. And so I know that FM, that line, is the perpendicular bisector of segment BC in triangle ABC. Now, we have a line in this case, but it's also important to know that a segment or ray could be the perpendicular bisector as well. Okay, so a segment or ray could be a perpendicular bisector. It says could here. of a side in a triangle. Now, the difference is here. Okay, so even though these triangles aren't drawn super well, this triangle here, we started here at vertex A and dropped the altitude straight down. So I don't know anything about BD and DC. All I know is that this right here has formed a right angle. Over here, I have, if I were to draw this a little bit better, I can see vertex A is right here and F is right there. Another way to look at it is to look at it like this. So if I were to draw my perpendicular bisector, all right, that's what it would look like. Okay, so it's important to notice that this one here does not go through the vertex. Okay, the altitude would come straight down right here. Okay. Okay, so let's look at some other important things that we should know. So angle bisectors, medians, and perpendicular bisectors are all going to lie inside the triangle. Now let's see why. So if I draw my angle bisector, that's going to come right through here, okay, to make this congruent to this. So this guy here is my angle bisector. Okay, if I were to look at my median, okay, the median's going to come through here, but it's going to cut this congruent in half. So this guy right here is my median, okay, and then if I look and want to have my perpendicular bisector, the perpendicular bisector is going to go right through here and make this like this, and again, those are congruent. So in blue, we have the perpendicular bisector. Okay. Now, altitudes can lie inside or